is what we have. This is what we want. So what's your thought? Sine over cosine. Cosine over sine. Get two fractions. Get a common denominator. So this one is going to be times by sine. And this one by cosine. Everybody still with me? So what do you have on the top? Sine squared plus cosine squared, 1. And then, because that's what you want to end up with, you might want to think about this. I'm not saying you have to write it down, but think about this as 1 over sine times 1 over cosine. And that will give you your cosecant and your secant. Does anybody have a question about that? Okay? All right, we'll look at some of last night's, but I have some notes I want you to take first. I promised yesterday that we would get some new identities today, and we're going to get them. Get your pink sheet out.
Gold.
Or gold, I'm sorry, your gold sheet. Get your gold sheet out. And underneath, you know, you've learned your Pythagoreans, your reciprocals, all that. The next category is called the sum and difference identities. So today, we're going to talk about how to find the cosine, sine, and tangent of angles that are added together or subtracted. Okay? Now I want to clarify how they are written on the sheet. They are written on the sheet exactly as you will find them in every trig book under the sun. But it's a little bit confusing if you've never seen that before. Is the first one cosine?
Yes.
Okay. So what you see on your paper is cosine. This is sad, my hair is just falling out by the handfuls. I don't know if I can make it through tomorrow. I'll be bald by Monday, I'm sure of it. But cosine, what letters do they use? U and V?
Yes.
Okay, so I'm going to break them apart. I'm going to do U plus V and U minus V differently, separately. They put them together. The formulas are the same. The pattern is cosine of the first, cosine of the second, sine of the first, sine of the second. Both formulas use that pattern. If you're doing the addition, it's cosine, cosine minus sine, sine. If you're doing the subtraction, it's cosine, cosine plus sine, sine. They have them written on the paper with a plus or a minus. See that? But notice that one of them is plus minus and the other one is minus plus. The plus here goes with the minus here, and the minus here goes with the plus here. These are the formulas. Now, you will memorize, I hope. I think it's easier if you just memorize the pattern. Cosine, if I'm doing cosines of a sum or difference, it's cosine, cosine, sine, sine. If it's an addition, the formula has a minus sign. If it's a subtraction, the formula has a plus sign. Now, how does this work? What kind of problems do we do with this? Well, several. At the beginning, the first problems are things like this. Find the exact cosine of 75 degrees. Now, on your last test, in your last chapter, you learned how to find exact sines and cosines. What angles were you able to find exact sines and cosines and tangents for? 30, 60, 90, 45, 45, 90, right? Keeping in mind, of course, that when you say 30 degrees, you don't mean just 30. You mean 30 in quadrant 1, but you also, remember the butterfly bow tie? You also could do a 30-degree angle in quadrant 2, which would be 150. So you could do 30 and 150. You could do 210 and 330. So when we said 30, 60, 90, we're really talking about all the 30s, all the 60s, all the 45s, right? Okay, so there's a lot more than just 30, 60, and 45. Well, 75 is not in that list. 75 is new. So how are we going to do 75? Well, think about 75 as the sum or difference of two of your special angles. Can you think of two of your special angles that either add up to 75 or subtract to 75?
45 and 30.
45 and 30. That's kind of an obvious choice. Are there other options? Yes. But I'm going to use 45 and 30 because that's the easiest. Now, some of you are going to be tempted to do this. No. We wish it were that simple. It is not. Cosine does not distribute. If you want to find the cosine of a sum, you're going to do this right here. This is your U, that's your V. Xavier?
Do those stand for something? Or are those just...
What, the U and the V? Yeah, those are your variables. Those are the angles. In this case, 45 and 30. It's like X and Y. Mr. Thompson typed that sheet. I don't know why he used U and V, but he did.
So those don't like have...
They have nothing to do with anything. They're just variables. So in our problem, our U is 45 and our V is 30. So what's our formula going to say? Cosine 45, cosine 30. That's it exactly. Everybody see it? Cosine, cosine minus sine, sine. That's the formula. See it? Now you get to go back and plug in these four values. So if you thought you were done with that when you took your chapter 4 test, wrong. You're never done with it. We use that forever. If you have those numbers memorized, awesome. I do not. So up in the margin of my paper, I'm going to draw a 45, 45, 90 triangle and a 30, 60, 90 triangle. So that I have my 45 and my 30. I'm just going to plug in my numbers, okay? So what's the cosine of 45? 1 over root 2. We're going to write it as root 2 over 2. And so is the sine. Would you agree with that? Cosine 30. No cosine. Adjacent over hypotenuse. X over R. Root 3 over 2. Cosine's root 3 over 2. And the sine is 1/2. Don't forget your SOHCAHTOA. Okay? Now, those two can be multiplied together, so that would be root 6 over 4. Those two can be multiplied together, root 2 over 4. They have the same denominator. However, these are not subtractable because in radical land, if you're going to subtract, you have to have the same thing under here, right? So we just have root 6 minus root 2 over 4. That is the exact cosine of 75 degrees. All right, let's try another one. All right, let's try this one. Let's find the exact cosine of 165. Whoa, 165. Okay, You gotta think of two things
Oh, 2 cents.
that either add up or subtract to give you 165. And the two things you think about have to break down to 45, 60, or 30. So you know the thing I erased up here where I had the 30s? I said 150 could be used and 210 could be used. Well, that's a big number, so you're gonna have to use something like that. How are we gonna get 165? Can you think of two numbers that add or subtract to 165? Xavier? Why's your hand up?
I was thinking at first.
Oh.
I put it back down.
Jack?
135 and 30.
Oh, there's an idea. Oops. 135 and 30. I like that idea. Now, there are tons of ideas, kids. There's lots of different ways you can do this. I was thinking 120 and 45 myself, but this is fine. Why is 135 acceptable? Why is it okay to use 135? Because the reference angle is 45. The only thing is, Jack and everybody else, pay attention, what quadrant are we in? Which means that guy is negative, and that's important. You have to make that negative. Okay, what's my formula? Cosine 135 plus 30. It'll be cosine 135, cosine 30, sine 135, sine 30, cosine, cosine, sine, sine. That's the pattern.
When will like it be negative, like 135 plus 30? Like when will that be negative?
If you were writing 225 minus 60. However you choose to write your angle, you can either add to get it or you can subtract to get it. All right, here we go. We're gonna plug in some numbers. Shoot, I erased my 30. I like to just leave them up in the margin, but I'm only on one board. That's hard to do. There's my 30. So the cosine of 30 is root 3 over 2. And the sine of 30 is 1/2. Everybody okay with that? Now the 135s, be careful. The cosine would be what? Negative root 2 over 2. And the sine would be positive root 2 over 2. Everybody okay? So we've got negative root 6 over 4 minus root 2 over 4, which is negative root 6 minus root 2 over 4. Now, the two answers that I got aren't identical, but they're very similar to each other. Do you expect that might happen when I do these problems?
Yes.
Why?
Because
They're all the same angles. They're all versions of 30, 60, and 45. So these are the numbers I'm going to keep getting over and over again. Sometimes positive, sometimes negative, but those are the numbers I'm going to get over and over. Got it? All right, let's look at the sine. If you look at your sine identities on there, again, they are written together. I'm going to separate them. But the good news is, they're exactly the same, just like the cosine is. The cosine formulas are. Pattern's a little different. For the sine, the pattern is sine of the first, cosine of the second, cosine of the first, sine of the second. Sine of the first, cosine of the second, cosine of the first, sine of the second. However, with the sine identities, this is how I remember it, the signs stay the same. For the sine, the signs are the same. S, 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 S. For the sine, the signs are the same. So if this is a plus, this is a plus. If this is a minus, this is a minus. Did I have a mistake, Jason?
No, I was just waiting for when it's cosine, if you're adding and you subtract.
Yep. Yep. For the sine formulas, the signs are the same. For the cosine, they are not. All right, you ready to try one? Let's do sine 285. All right, so what's the first thing we have to do?
Break it down.
Yep, gotta think about how we're gonna get 285. I'll give you a little hint. Anytime mine ends in 5, I think 45. So if I were gonna use 45, this would be the sine of 240 and 45. Now, is 240 okay? 240 is fine because what's the this is 180, this is 240, what's that? 60. So it's perfectly okay to use 240. Are there other ways to get 285? Yes. Please do not think there's only one way to do it. 130 and 135 and 150 would be an option. I like to use 45 anytime I can because it's so easy. Okay, so what's my formula say? Sine 240 plus 45. Here we go. Sine 240. Cosine 45. There we go, you're right. You got it. And then just like before, we're going to plug in numbers. We did the 45s already. And since the 45s are both the same, I don't have to worry about getting mixed up. What's the sine and cosine of 45? Root 2 over 2. Now I got to do my 240, and I've already drawn part of it
Does it have
here.
anything to do with being in like the third quadrant?
Oh, does it matter it's in the third quadrant? Absolutely it does, because these two are both going to be negative, right? Now it's not going to impact the numbers. This is still root 3, this is still 1, and this is still 2. But these are negative. So the sine will be negative root 3 over 2. And the cosine will be
So you're just looking off the angle 60.
So I end up with negative root 6 over 4 minus root 2 over 4, negative root 6 minus root 2 over 4. Same numbers I got before. Everybody okay? All right, let's do tangent. Tangent is done exactly the same way. It's not hard or complicated, but because the formula is a fraction, there is always extra arithmetic involved. You'll see what I mean. Formulas for the tangent. The pattern for the tangent is tan U, tan V over 1 tan U, tan V. For both of them. If you're adding, if it's a plus problem, if you're adding, then you got the plus on top and the minus on the bottom. If you're subtracting, then you have the minus on the top and the plus on the bottom. Now, I will tell you how I remember that. You can take it or leave it. You remember how I remember to keep sine and cosine straight. I know one of them stays the same and one of them's different. Signs stay the same. SSS, signs stay the same. I know that tangent is sine over cosine. So I have the same sign over the different sign. Because its sine stays the same over cosine. So I remember that's a plus and that's a minus. If that's a minus, that's a minus, and that's a plus. The signs stay the same. Since tangent is sine over cosine, I have the same sign on top and the different sign on the bottom. Okay? Now, how does this work? Well, starts out the same exact way. Let's try, let's do the tangent. I already did a 165, didn't I? Let's do a tangent. 255. Did I do 255 already? No. Alright, let's do the tangent of 255.
210 and 45.
210 and 45 would be a great choice. Not the only choice. So if you pick different numbers, all this will look different, but your answer will be the same. Alright, so here we go. Formula says tan 210 plus tan 45 over 1 minus tan 210 tan 45. What do you think? Everybody good with that? Jayon, why are you shaking your head no? Formula. My U is 210, my V is 45. Just plug it right in that formula. Now, 210. Tell me about 210. What's the reference angle for 210? 30. So this is 1, this is root 3, and this is 2. However, I'm in quadrant 3. So this and this are both negative. $45. There it is. So let's start plugging numbers in. What's the tangent? Excuse me. What's the tangent of 210? 1 over root 3, which is root 3 over 3. What's the tangent of 45? 1. This is actually root 3 over 3 times 1. I just didn't write the times 1 part. Okay? Now, when I started this, I said because the tangent is a fraction, it always involves more arithmetic. So what we've got here is one of those big complex fractions, a big fraction with some little ones in it. What am I going to multiply by to take care of that? 3. So I'm going to multiply everything by 3. Kendall, would you let me finish, please? Then I'll get you. So we're going to multiply through by 3. That's going to leave me with root 3 plus 3 over 3 minus root 3. Everybody see that? Now I know that's full of root 3's and 3's, but you can't cancel any of them. You understand that, right? There's no canceling in this problem at this point. However, you do have to fix this. This is a problem. How do we fix that? Multiply by 3 plus root 3. Gang, I could have done that over here, but I didn't want to mess with those fractions. I want to get those fractions out of there first. Now I'm going to rationalize, multiply top and bottom. So now it just becomes a big FOIL problem. So I am going to FOIL first, outside, inside, last. First, outside, inside, last. So what have I got? 12 plus 6 root 3 over 6. Now can I cancel anything? Yeah, now I got my triangle going. I can cancel. 2 plus root 3 is the answer, the exact tangent of 255. Okay? So tonight, you will do a few problems like that, using those identities. Okay? What I want to do for the rest of our time, though, is hit any problems you had last night. Yes, I'm sorry.
How did you get the on the bottom?
It's like and then a side.
Tangent of 2/10, it's the same number.
But it's just tan, 2 times and tan 45. So you just do
Tan
1.
45 is 1. These are being multiplied.
Oh.
Anything times
So you just
1.
skip the step.
Well, I said this is technically times 1, but I wasn't going to write it down because times 1 is the same thing. You don't need that. Negative sign. You don't have a negative inside. Just negative sign. Okay, did anybody find, in the list that I gave you to pick from, did anybody find one that was just a little bit more than you could handle? Sienna? With 16? All right, let's look at 16 and see how it comes out. How did you start it, Sienna?
I changed tangent, cosine over cosine, and then seek it into whatever cosine.
Absolutely. And when you did that, it came out with a common denominator. So this is where you were. And at this point, this is a great problem, I'm glad you asked about it. At this point, remember, nothing here is squared, boys and girls. You aren't going to change sines into cosines unless they are squared. So at this point, I'm going to stand back, look at what I have, look at what I want, and I'm going to say, I have to have a cosine in the numerator. I have to end up with a cosine in the numerator. So by golly, I'm just going to put 1 in there. Now, is that legit? Absolutely, as long as I also put 1 in the denominator. It's completely okay. Now, that leaves me with sine plus 1 times cosine over cosine squared. Okay, now wait a minute. Cosine squared. I need sines in the bottom. Can I turn a cosine squared into a sine? Yes. So now I'll have sine plus 1 times cosine over 1 minus sine squared. That's what cosine is. It's 1 minus sine squared. That's what cosine squared is, right? Now, kids, what are you going to do with that denominator? Factor it as the difference of squares. And as soon as you factor it, have what we wanted. Okay? So that's the little thing we hadn't talked about before. But if you can't figure out how to get what you want, just stick it in. Hopefully it'll work out. Just stick it in. Kendall?
35.
35. You know what? This looks a lot like what we just did. Let's talk about this for a minute.
35.
Okay, let's talk about what is running through my mind. I'm thinking I could change into sines and cosines. Here's my issue with that. What am I trying to end up with? Secants and tangents. What do I have right now? Secants and tangents. So as a last resort, I can change it all, but then ultimately I'm going to have to change it all back. That's okay. But what if we kind of did the same thing that we did with this problem? Notice nothing is squared. Tangents and secants are linked by the identity. But you can't do the identity unless something is squared. So her suggestion is, Caroline's suggestion is, multiply the top and the bottom by secant plus 1. Now, here's her logic. Well, I don't know. Here's what I think her logic is. Either I gotta have a secant plus 1 in the numerator, or she's thinking if I do that, this is gonna give me a secant squared in the denominator. Either logic is perfect, because they're both gonna be good. So you've got secant plus 1 times tangent over, what's this when you FOIL it out? That's a FOIL. What's that gonna be? Secant squared minus 1. Whoa, 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 whoa. Secant squared minus 1. That's tangent squared. And what's going to happen now? The tangents are going to cancel and you're going to be left with what you wanted. All right, one more. Kendall.
Sorry. 28.
28.
I don't know if it's the same, but
No, it's not quite the same, but here's the idea. Part of it's the same, because I'm going to suggest that since you have cotangents and you want tangents, that instead of changing into sines and cosines, maybe we would change the cotangents into 1 over tangent. Does that make sense?
Yeah.
Because this is what I'm shooting for. So 1 over tangent for both of those. Okay, now I've got one of those complex fractions. So what could I multiply by to take care of that problem? Tangent.
so you multiply tangent by each little piece.
Mm-hmm. Yeah, we talked about that. That's how you clean up a complex fraction. And what's going to happen? I'm going to be left with what on top? 1 minus 10. And on the bottom, 1 plus 10. Does that make sense to you? Well, that only took a minute, so I can do another one. Is there another one, Caitlin?
Number 18.
18.
Is that like one of them?
I don't know. Let's see. Let's look at 18 and see. First thing I notice when I look at 18 is that my numerator, I've got secant squared minus 1 over sine. So sine over 1 minus sine squared. My numerator is a identity. What is secant squared minus 1? So I got tangent squared over sine. What would you suggest I do with that tangent squared? Switch it to sine squared over cosine squared. Is that okay? Now it's divided by sine, so it's times 1 over sine. Yep, it's multiplications, you're allowed to do that. So it would be sine over cosine squared.
Which is equal to.
But cosine squared is 1 minus sine squared. Does that make sense, Caitlin? Okay, gang? Homework for tonight. You have a quiz over this stuff on Monday. Tomorrow I will give you one more practice problem. You got one yesterday, you got one today, I'm going to give you one more tomorrow. Monday you have a quiz over. I'll give you a problem to you for real.
Well, that packet helped us that you gave us.
I'm probably not with this. I will have homework for some of that in there. Okay. Tonight's homework. We are on page 468, 5.3. 1 to 21 on. Yep, 5.3, 1 to 21 on. That's your homework. Everybody hear me?
Yeah.
If you don't have your identities memorized, get them done. You gotta know them, gotta know them, gotta know them. Do I have any more extra copies of my practice papers floating around back there? Oh, you need to take care of this stuff.